Hi folks. So today I've come up with a list of problems from part B for 2 markers. Now the only reason behind giving this list of problems is so that you put more preparation or you are thorough with these problems along with other problems. Just don't rely on these problems and ignore the other topics and other problems. Practice the problems given here well so that it can help you in your preparation. So let's go through this list chapter wise. So first let's go through matrices chapter. So here is the list of questions. So I've solved these problems here. The first one is a matrix will be given. So we'll have to find out 5 times of that particular matrix or 3 times of that particular matrix, or you have to find the transpose of the matrix and multiply with a number. So these kind of questions. So when you have to find the transpose, you'll have to interchange the rows and columns. Whatever is in the form of a row, you'll have to put it in the form of a column and then multiply it with whatever is given in the question. So this is in the case of when transpose is given. This A dash indicates transpose. Here, this is another kind of problem where 3 matrices are given. You'll have to solve them. That is, you have to find 2A minus 3B minus C, right? So you multiply the matrices and get the final matrix. The third type of problem is you'll have to find X and Y, right? So what you'll have to do is wherever you have X and Y, whichever elements have X and Y equated to the corresponding element in the other matrix. So you have X plus Y equated to 4. And here also you have X minus Y equated to 8, the corresponding elements, right? And then you get 2 equations. Then you can try to eliminate one of the variables, right? By adding or subtracting, you try to eliminate. So you get the value of y. Take the value of y and substitute in one of the equations. You'll get value of x. The next type is 2 matrices are given. You'll have to find the product of these matrices. A into B, B into A, right? Then fifth type is a matrix expression is given, right? Like A square minus A minus 3i is equal to 0 or O. 0 or O, this is nothing but a null matrix. This is a null matrix. That is a matrix with all zeros. So you'll have to evaluate this, right? A square, multiply matrix A 2 times, subtract with A, then subtract with 3. And I is identity matrix, right? That is, you'll have like this. You'll have the diagonal elements as 1 and the other elements as zeros, right? So 3 times of identity matrix here, 3 times of I. So solve this. And you have to get a null matrix, that is matrix with all zeros. That's when you can say that this particular expression is proved, is true. And here in this particular example, you have an expression given, A plus B plus C is equal to null matrix or a 0 matrix. 2 matrices are given, you have to find the third matrix. So first what you have to do is, whatever matrix you have to find out, keep that alone in one side. Keep it on the left hand side, right? Keep it on the left hand side always. And that everything else, right, should be shifted to the right hand side, right? Only this matrix that you want to find out, you will have to keep it in the left hand side. So once I shift everything, now 0 matrix is nothing but matrix with all zeros. Matrix A, matrix B. So solve this and you'll get matrix C. So this is another kind of problem where a matrix is given. Without expanding, you'll have to prove that determinant, right? This notation is nothing but determinant, right? You have to prove that the determinant of this particular matrix is 0. So there are multiple properties of determinant, right? There is a separate video on determinant properties. So you'll have to remember all these properties if you have to solve such kind of problems. Now, one of the properties is you have to make the rows identical. If you can make the rows identical, then determinant becomes 0. There are few properties in which the determinant becomes 0. One of them is if the rows are identical. The other one is if any row or any column has zeros, then the determinant is 0. So now here we will try to make 2 rows identical. So what we will do, we'll add this row and this row, right? Second row and third row, when you add, you will get x plus y plus z, x plus y plus z. So basically you have to ensure that you make the elements similar, right? So if I add this with this, it will become x plus y plus z. If I add this with this, again I'll get the same thing. If I add z with x plus y, I'll get x plus y plus z. So that way I've got common element. Once I've got the common element, I can take common factor. When I take the common factor, I'll get 1, 1, 1 here. So now you see, I have 2 identical rows. Since 2 rows are identical, I can say determinant is 0. Now this is another type of problem where again you have to prove that determinant is 0. So what I will do is, I will try to add all the column elements, right? So when I try to add all the column elements here, it's going to become 0. If I add this with this, and this with this, this with this, like this. When I add this with this, and this with this, all the elements will get cancelled and it will become 0, like this. One column has complete zeros. So thereby I can say the determinant is 0. There is a detailed video on determinants where multiple problems related to determinants have been solved, right? Many problems have been solved related to determinants. So you can refer that video in the playlist. And then there could be some theoretical questions, like, where you have to prove that determinant changes its sign when any two of its rows or columns are interchanged. Or you will have to prove that if all the elements in a row or column are zeros, then the value of the determinant is 0. You have to prove the determinant properties. Again, there is a separate video on determinant properties itself, on the proofs. This is another type of problem. You have two expressions given, right? 2a plus b is equal to 1 matrix, a minus 2b as 1 matrix. You'll have to find a. So in these cases, again, normally when you get equations, how do you find the values of a and b or x and y? Same way. You consider that this is one equation and this is one equation. You try to eliminate one of the variables. I want to eliminate b here because I need to find a. So I'll try to eliminate b. To eliminate b, here in this expression I have plus b and here I have minus 2b. If I multiply this entire thing with 2, then I'll get 2b here, right? If I multiply this entire thing with 2, I'll get 4a plus 2b. Then I can add this and this. Once I add, 2b and 2b will get cancelled like this. 2b and 2b will get cancelled. I'll get 5a. And then I can figure out what a is by shifting 5 to the other side. This is the next topic, parabola. Practice on these kind of questions also, along with other questions. So you generally have to find the equation of parabola, given different kind of parameters. They could give directrix, or they could give focus, or they could give you axis, or they can give you a point like this, right? Or they can give you an equation of the parabola and ask you to find the focus and equation of directrix, right? They can ask you to find the focus or equation of the directrix. So different kind of problems are given here. Practice these problems. Now, there is a revision video where all of these problems are solved and explained. Go through that revision video. It will become very clear with this particular video. Limits and continuity. Let's focus on continuity, right? In continuity, you have 6 to 7 problems in the exercise. Solve all the problems, right? Solve all the problems. I've given some problems here, right? But it's worth solving all the problems. And there is a revision video where I've taken all the problems of the exercise and explained and solved it. This is an easy 2 marker. The steps are less, calculations are less, yes, but you'll have to remember certain limits formulas, right? But it's worth it. Go through the revision video. Now, this particular topic is mathematical logic. There will be some propositions given, right? You'll have to find the converse, inverse, and contrapositive. Then the other type of problem would be the truth values of the propositions are given. Say the propositions are P, Q, and R. The truth values are given. Now, using the truth values, you can find the truth value of this entire compound proposition. Then the other type is compound proposition is given, right? And the result of this proposition is false. You need to find the truth values of P, Q, and R. Reverse of this particular question. Then negating the proposition, right? You'll have to find the negation of this entire expression. I've solved these problems here. Let's go through them. So let's take this problem. If the questions are easy, then students score better marks. First, get it into the symbolic form. You first break these propositions. Split the propositions. The questions are easy. Say it is proposition P. Students score better marks. Proposition is Q. Now, how is it connected? There is if and then. If and then means it's a conditional statement. It's a conditional proposition. So P conditional Q. Now, this is the symbolic form. Now, from this, you will try to find converse, inverse, and contrapositive. What is converse? Just reverse the propositions, right? Just reverse. Here you have P conditional Q. Reverse it. Make it as Q conditional P. So reverse it. Students score better marks. So you keep if and then as it is. If and then as it is. Just swap interchange the propositions. So if students score better marks, then the questions are easy. Inverse. Inverse is negate the propositions, put a not, right? Now you have P conditional Q, the original symbolic form, negate it. So instead of P, make it as not P. That is, if the questions are not easy, then students don't score better marks. So you see this additional not here. Now what is contrapositive? Contrapositive is reverse of this, reverse the inverse. That is, reverse this, interchange this, like this. Bring not Q here and not P here. If the students don't score better marks, then the questions are not easy. Again, retain if and then everywhere as it is, right? Everywhere there will be if and then in the same place. The propositions keep changing. Now this is an example where the truth values of the propositions are given. The truth values of P, Q, R are given. P is false, Q is true, R is false. Now you need to find the truth value of this particular proposition. Now you will have to remember the truth values for P conditional Q. The way to remember is, in P conditional Q, the only case when it is going to be false, is when P is true and Q is false. Everything else is going to be true. Only this case it's going to be false, where first proposition is true, but second proposition is false. So now, instead of these propositions, put the truth values for each of the proposition. P is false, Q is true, R is false. Now, first let's solve what is there within the brackets. First priority, importance should be given to the proposition that is given in the bracket. So, Q conditional R, that is true conditional false. When you have true and false, what is the result? False. This is going to be false. And here you have false here. Now, false and false is true, right? False and false is true. So, the answer is true. Now, here compound proposition is given. The final result is false. The final truth value of this proposition is false. I have to find the truth values of P, Q and R. It's a reverse of the earlier question. So I have to find the truth values of P, Q and R. So what I'll do is, the final result is false of this entire expression. When is it false? Let's look at it. When is it false? When is it false? Only when first proposition is true and second proposition is false. T and F case. Right? Now, here it has to be false. That means first proposition has to be true and this proposition has to be false. You consider this entire thing as, say, Z. Just visualize that this is Z, this entire expression. Now it will be conditional Z. So this result is false only if first proposition is true and second proposition is false. That means this entire thing should be false. Q disjunct R is false. Means one of these can be false or both of these can be false, right? So we will take both of them to be false. Q is false, R is false, then the result is false. So we have P is true and Q is false and R is also false. Negate the proposition. You'll have to remember all the laws, De Morgan's laws especially, right? All the negation laws, all the De Morgan's laws, you'll have to remember. These are the key laws. So we'll have to remember this when you are solving these kind of problems. Now, negate means take the entire compound proposition and negate it, right? So now the law states that if you have negation of this kind of a proposition, you have conjunct here. So it will become reverse. You have conjunct, it will become disjunct. P conjunct Q is not P, disjunct not Q. So apply that property here. Here the connectives, these connectives will become reversed. So here if you have and or conjunct, it will become disjunct or, right? If there's an and condition, it will become or condition. If it's an or condition, it will become and condition. And here, when you have P conditional Q, when you have not of P conditional Q, what is it? It is when you have conditional, you'll have to put conjunct, right? And if you have biconditional, then you have to put this way. So this law we are applying here, this particular property here in this particular expression. Let's come to the fifth topic, which is ratio and proportions. There can be questions coming from any nook and corner of this particular chapter. That is why it's better you go through the revision video for ratio and proportions, where all the problems, all the different problem types have been covered. You can focus on these problems here. Ratio is given in the lowest terms, that is the simplest or smallest value. If the difference between the quantities is 24, find the quantities. Quantities is numbers. So you assume that you have two numbers, right? You have two numbers, 3x and 7x, right? And the difference between them is 24. Then you need to find these numbers. Similarly here, two numbers are in the ratio 3:5. If you add 5 to this ratio, then the new ratio will become 2:3. Find the numbers. What must be added to each term in the ratio 5:6 so that it becomes 8:9? What must be subtracted from each term in the ratio 7:4 so that it becomes 5:2? If 10 persons can do a job in 30 days, in how many days can 15 persons do the same job? Now, there are multiple such problems, right? This is just an example, but these kind of problems we need to know how to solve. Then the other one is monthly incomes of A and B are in the ratio. Their monthly expenditures are also given as a ratio. If each of them saves rupees 100 per month, find the monthly incomes of A and B. Again, all these problems are solved in the revision video. You can refer that. Then divide rupees 6,000 in the ratio 3:4:5. If A is to B is equal to 4:5, find this particular value. Then if A is to B is 2:3 and B is to C is 6:30, find A is to B is to C. Bill discounting. Here are a few key problems from bill discounting from part B and part C, right? We'll go through each of these questions. So first one, find the banker's discount on a bill of rupees 415 due 9 months at 15% per annum. You need to find banker's discount. What is banker's discount? Banker's discount is nothing but the simple interest calculated on the face value. So if face value, F is the face value, right? Simple interest calculated on this. What is simple interest formula? What is simple interest formula? It is PTR by 100, right? But here, instead of putting PTR, you put FTR. So this becomes banker's discount, right? Now this is one way of remembering this particular formula. Now FTR. So F is 415 face value. T is 9 months. T should be represented in years. So it is 9 months. So it's 9 by 12. R is the rate of interest. So just substitute all these values in this particular formula and you'll get banker's discount. Here's the second problem. A banker pays 2,380 on a bill of 2,500 73 days before the legally due date. Find the rate of discount charged by the banker. You have to find R. So face value is given. Face value is 2,500, right? Bill of 2,500. So this is the face value. Banker pays 2,380. That means this is the discounted value, right? Since the banker is paying, it is nothing but discounted value. Discounted value is 2,380. T is 73 days. From the 73 days before the legally due date. So now 73 days before the legally due date means its date of drawing, which is 73 by 365, which is 1/5 of a year. What is the discounted value formula? We'll have to use the discounted value formula, which is F into 1 minus TR, right? F is 2,500. T is 73 days before the legally due date. So you have to first find T in terms of years, right? It is 73 days, convert it to years. So it will be 73 by 365, which is 1/5. So when I substitute, I'll get R as 24%. Let's look at the third problem. A bill drawn for 3 months was legally due on this particular date. Find the date of drawing of the bill. Simple, right? What is legally due date? It is nothing but when I add date of drawing with 3 grace days and the bill period, I get the legally due date. Now in this question, legally due date is given. You have to find the date of drawing, right? You have to find this and legally due date is given. So what I'll do, from the legally due date, I will subtract bill period, I'll subtract grace days and I will get date of drawing. So 6th July 2018. If I remove 3 months from it, it's going to be April and 3 days before 6th, which is 3rd April 2018. Let's go to the fourth problem. A bill for rupees 12,900 was drawn on 3rd Feb 2014 at 6 months and discounted on 13 March 2014 at 8% PA. For what sum was the bill discounted? So for what sum was the bill discounted? This means you have to find the discounted value, right? So the actual face value of the bill is 12,900. Bill period is 6 months. It is drawn on 3rd Feb, which means it's the date of drawing. Date of discount is 13th March 2014, right? This is date of discount. R is given as 8%, which is 8 by 100, which is 0.08. So you can use two formulas for discounted value, right? You can either use face value minus banker discount, or you can say discounted value is equal to face value into 1 minus TR. Either of these formulas you can use, right? I've used banker discount. You can also use this particular formula. Face value is there, R is there, we don't know what T is, right? How do we find T? They have given drawing date, they have given the bill period, which is 6 months. So with that, you can find legally due date, right? Drawing date is 3rd February, 6 months is the bill period, 3 days is the grace period. When I add all this, I'll get legally due date. Now I'll count the number of days from 3rd February to 6th August days. It's 146 days, right? So I'll put 146 by 365 here. Either use this formula or this formula and you'll get the discounted value. Let's go to fifth problem. Banker's discount and banker's gain on a certain bill due after some time are rupees 1,250 and 50. Find the face value of the bill. So you have to find face value. Banker discount is given, banker's gain is given, right? Now, what is the formula for face value? Straightforward. Banker's discount into true discount by banker's gain. This is the formula, right? To get the face value. We have banker's discount, we have banker's gain, but we don't know what true discount is. So we'll have to find true discount. Then we'll have to use another formula. What is the formula for banker's gain? Banker's gain is banker's discount minus true discount, right? Banker's gain is banker's discount minus true discount. So you know banker's gain, you know banker's discount, find the true discount. So you'll get true discount. Now take this true discount value and put in this particular formula here, right? So I'll get the face value. Sixth problem, banker's gain on a bill due 6 months. So bill period is there at rate 4%, R is there, is 20. So banker's gain is 20 rupees. Find the true discount, banker's discount and bill amount. So let's find true discount. True discount is there in two formulas, right? One is this one, TD is BG by TR. Second one is in this particular formula, in the banker's gain formula, you have true discount. Now we'll use this particular formula. Reason is we have banker's gain. We know the time, right? Time is 6 months, which is 6 by 12. We know R, which is 4%. So we can use this formula and get true discount directly. We know true discount, we know banker's gain. So we'll find banker's discount. We need to find the bill amount. What is the bill amount? This is nothing but the face value. This is nothing but the face value. So we'll use this formula. BD is equal to FTR. We anyway know what is BD by TR. So we'll substitute banker's discount and time and rate and you'll get the face value. Let's look at seventh problem. The banker's gain on a bill is 1/5 of the banker's discount. Rate of interest is 20%. Find the unexpired period of the bill. So unexpired period is nothing but T. So banker's gain is 1/5 of banker's discount. R is given 20%. We need to find T. We can use true discount formula. Here you have T, right? So in true discount, the formula is FTR by 1 plus TR. We don't know face value. We have to find T and R is given. So what we will do is we'll use an additional formula, which is face value is equal to BD into TD by BG. BG is 1/5 of BD. So now here BD and BD will get cancelled. We'll left with 5 TD. So face value is 5 times of true discount. Now we substitute, instead of F, we put 5 TD. So here TD and TD will get cancelled and you can find out the value of T. T is 1.25 years. Let's go to eighth problem. For rupees 512.50, due 6 months, so bill period is 6 months, R is 15%. Find the true present value and discounted cash value. So we'll have to find the present value. What is the formula for present value? It is F by 1 plus TR. So F is given here. This is 512. T is 6 months, so 6 by 12, which is half. And R is 15% here. So now you substitute, you'll get the true present value. What is the formula for discounted cash value? It is F into 1 minus TR. So substitute face value, substitute T and R. You will get discounted cash value. Let's go to the ninth problem. The banker's discount and true discount on a sum of money due 3 months are rupees 154.5 and rupees 150. Find the sum of money and rate of interest. So due 3 months. So bill period is 3 months. Banker's discount and true discount are given. This is banker's discount and 150 is true discount. Find the sum of money. Sum of money is nothing but face value and you have to find rate of interest. So banker's discount is given here 154.5. True discount is rupees 150. We need to find face value and we need to find the rate of interest. Time is given as 3 months. That is 3 by 12, which is 0.25 years. Now what is the formula for BD? BD is equal to FTR. So here you have F and you have R, right? So we don't know F, we don't know R. We know T and we know banker's discount. Now we'll go to the other formula. We'll go to the true discount formula. What is true discount formula? FTR by 1 plus TR. Again here also we don't know F, we don't know R. We'll substitute everything else. So what we can do is from this first equation, from the BD equation, from the banker's discount equation, you can find out F, right? You can just find out F here. So it will be 154 by 0.25 R. So now that F will substitute here in the true discount. Instead of F, we'll put 154 by 0.25. And then F is substituted. Now we'll have to find R value. So R you will get as 12%. Now we'll have to find face value. So we'll come back to this equation. Right? We know R, we'll substitute R, we'll get face value. Let's go to 10th problem. A bill for rupees 3,500. This is the face value. Due for 3 months, bill period. Drawn on 27th March, so drawing date is given. Discounted on 18th April, so discount date is given. At the rate of 7%, R is 7%. Find the banker's discount. Now what is the formula for a banker's discount? So here, it is slightly tricky, right? Time is given as 3 months, right? But you should not put T as 3 months. Right? you have to find the unexpired period. That is, you have to take from the drawing date till the discounted date, you have to calculate the number of days, right? That number of days will become T. T is going to be the number of days between drawing date minus discounted date. So drawing date is 27th March and discounted date is 18th April 2015. So when I calculate, I will get 73 days. I will get 73 days, right? Now I know what T is. So now, what is the banker's discount? So banker's discount is F into TR. F is 3,500 into time is 73 days by 365. R is 7%, 7 by 100. So when I calculate this, I'll get rupees 49 as the answer. So this is banker's discount. Let's go to the 11th problem. True discount on a bill was rupees 100. Banker's gain was rupees 10. What is the face value of the bill? So true discount is given. Banker's gain is given. We need to find the face value. Where do we have face value? In which formula? So in banker's discount, we have face value, right? So now we know banker's discount. Also banker's gain is given. What is the formula for banker's gain? Banker's discount minus true discount. Banker's gain is given and true discount is given. We can find banker's discount here. From this formula, we can find banker's discount, right? Banker's discount would be BG plus TD, right? We have both BG and TD, right? So here we'll find banker's discount, which is 110 rupees. Now we'll substitute 110 here. Face value we don't know. TR also we don't know. That means we'll have to use third formula. These two formulas are not going to help us. We'll have to use BG is equal to TD into TR. TD into TR. We know banker's gain. We know true discount. We'll find TR here, right? We'll find TR here. So we'll get TR is equal to 0.1. Now use this TR here. Whatever TR you get, use it here in this formula. F is there. We know banker's discount. We got 110, right? Now using this, we can find face value, right? So face value is going to be 1100 rupees. This is little tricky because three formulas have to be used. So ensure that you remember all the formulas, all the variations of the formula if you have to solve this problem. Last problem, the banker's gain on a certain sum of money. Certain sum of money means face value due in 6 months. T is 6 months. Banker's gain is 27. Find the face value of the bill if the rate of interest is 6%. So we need to find the face value. So we can use this particular formula for face value, which is BD into TD into BG. We know banker's gain. So here we'll use BG is equal to TD into TR. TD into TR because banker's gain is given. Now again, like earlier problem, you have to remember all the banker gain formulas, right? One formula is BD minus TD. The other formula for banker's gain is TD into TR. We know T, we know R, right? And we know banker's gain. So we can find TD, right? We can find true discount. Now, this is the other formula for face value, right? BD into TD by BG. So we'll get TD from here. We'll get TD from here. Put TD here. We know banker's gain, right? Now what is banker's discount? We have true discount. We have banker's gain. We need to find banker's discount. How do we find banker's discount? Use this formula. BG is equal to BD minus TD, right? So you'll get banker's discount. Now you substitute banker discount here, right? And I'll get the face value. So face value is 30,900 rupees. Probability. In probability, questions can come from any nook and corner of the chapter. So therefore, it's better you go through the entire revision video because all the different kind of problems, different types of problems are solved there with an explanation. So it's better to go through this chapter completely. But nevertheless, here are the list of questions that you can practice. But it is not limited to these questions. These are just, few of them. You will have to practice a lot more problems if you have to become thorough with probability. You will be given probability of A, probability of B. You have to find probability of, A by B or A or B or A and B, right? Similarly here, when you have this particular symbol, it means it's the complement of the probability, right? So this kind of problem also is solved in the other video. You can go through these questions. Permutations and combinations. Questions can come from anywhere in the chapter. So you refer the revision video, which is detailed enough. It explains all different kind of problems in permutations and combinations. Differential calculus. So here again, there are multiple types of problems in differential calculus, right? There are different methods, different formulas, right? There are detailed videos on differential calculus as well. All different kind of problems have been solved in the videos. But here I will go through some of the problems, right? So that conceptually certain things could be understood from this particular video. Here are some problem types that you may want to practice. Now let's go through solutions of each of these problems. This particular question, if y is equal to a square minus x square to the power 10, find dy by dx. So what you have to do is you have to apply chain rule. whenever you get a square, b square, c square, all that, right, that's nothing but a constant. And derivative of a constant, you know, is a 0. And derivative of x square, you have to use the formula. What is derivative of x to the power n? Derivative of x to the power n is n into x to the power n minus 1. N into x to the power n minus 1. So x square will become 2x. Right? Here you'll have to use chain rule because there are two functions here. Right? One is this power itself and this entire thing. This entire thing. So first try to solve the power. So you have power as 10. So it will be, you have to use this particular formula itself. You assume that this entire expression is one variable. You can assume this entire thing is t. So it will be t to the power 10. Right? What is t to the power 10? You have to use this formula. Right? T to the power 10 is 10 into t to the power 10 minus 1. 10 into t to the power 9. 10 into t to the power 9. What is t here? A square minus x square. Now you'll have to differentiate this a square minus x square. Derivative of a square is 0. Derivative of x square is 2x using the same formula. Right? So you have to apply chain rule here. Now this is another example. Differentiate of this one, you have to use this formula. 2 by 3 into x to the power 2 by 3 minus 1. Similarly for y also. And this is constant. So derivative is going to be 0. Here whenever you have y and you are differentiating it, always remember to put dy by dx. Right? And then also find the derivative of this one. Y to the power 2 by 3 is nothing but, you have to use this formula, 2 by 3 into y to the power 2 by 3 minus 1. And then do not forget to put dy by dx. So now you just get dy by dx and shift all the other values on the right hand side. You will get this particular expression. Now whenever you have negative power, you can bring it down, so it will become positive. So if I bring negative power here, it will become positive. So x to the power minus 1 by 3 will become x to the power 1 by 3. Y to the power minus 1 by 3 will become y to the power 1 by 3. You can take it to the top. This you can take it to the top and this you can bring it to the bottom. That way the powers will become positive. Now here, this is an example of an infinite series. You can assume y is equal to root x. Take the first expression. First expression is root x. Take that out. Then plus, what is this? What is this remaining expression? Y itself, right? What is y? Root x plus root x to the infinity. So here you have x. This entire thing is y. And then you have x left. You're taking the first term, which is x, right? And then entire thing with the root on top. So you write that like that. Then square on both sides so that you can eliminate square root. If I square root, it's going to become like this. Square and square root will get cancelled. So you'll get y square is equal to x plus y. Now you differentiate, right? Bring all dy by dx to one side and shift everything else to the other side. You will get this particular answer. Here, if y is equal to x to the power x, find dy by dx. Whenever you have variable as power, right? Apply log, right? Suppose you have x to the power sin x or x to the power x. So whenever you have such trigonometric expressions or variables, apply log on both sides. Now once I apply log, the reason I apply log is to eliminate this power, right? I don't want this power. If it is a number, it's easy for me to solve. But this is not a number, this is a variable. And here it's a function, it's a trigonometric function. In both the cases, I cannot solve this. So what I do, I apply log. When I apply log, it will be log y. And you have a logarithmic property, right? You can write this, right? M to the power n. M to the power n can be written as n log m, right? When I apply log. So I'll use this property here. So it will become x log x. This is the power. This is the power basically. This is power. So x log x. Now I differentiate, right? This way. Here I will get y. Substitute instead of y, put the original expression, which is x to the power x. Now here y is equal to cos x cube. How do I solve this? Simple. Use the chain rule. First take the power, right? First solve the power always. So what is the formula? N into x to the power n minus 1. So it will be 3 into x square. You have solved this function. Now you come to the trigonometric expression. Cos x cube. So what is derivative of cos? Minus sin x cube. That's all. Now here you have to find the derivative of root of tan root x. We want to remove this root. One way to remove the root is put square on both sides. When I apply square root and square will get cancelled. So I'll be left with this. Now you differentiate, right? Derivative of tan is secant square. And instead of root x, I can write it as x to the power half, right? So then I'll get this particular derivative. Here, like the earlier problem, you have power. So apply log, right? Apply log and then find the derivative. Now here you have to apply product rule because there are two functions here. It's a multiplication of two functions, sin x into log x. So apply product rule. Again, if you have questions on how to apply the chain rule, when to apply the product rule, when to apply logarithms, when to solve the infinite series problems, go through the differential calculus videos. This is another case where log and trigonometric functions are mixed. You will have to prove that the derivative is 2 cosec x. So here you have to use logarithmic properties, right? When you have log m by n, you can write it as log m minus log n. So here that's what I've done. Instead of division, I have put subtraction here. I have put subtraction. Now I'll use chain rule. First I will solve log function. So derivative of log is 1 by x, right? So instead of x I have 1 minus cos x. So I'm putting 1 minus cos x here. And then I'm finding derivative of cos x. What is derivative of cos x? Minus sin x, right? Similarly here also. Now I will cross multiply whenever you have rational functions. That is, whenever you have functions with divisions, just cross multiply, right? And then you apply trigonometric formula. What is 1 minus cos square x? It is sin square x. When you simplify this, you're going to get 2 sin x, right? So ultimately the answer is going to be 2 cosec x. Here, find the derivative if x square plus y square is equal to a square. Simple, right? Just differentiate on both sides. Separate out dy by dx. Shift everything else to the other side. You'll get this as the answer, minus x by y. Here, y is equal to x plus 1 by x. Now what do? Here you have to put division rule, right? You have to put division rule. What is division rule? Denominator into derivative of numerator minus numerator into derivative of denominator by denominator square, right? And find the derivative. Next topic, application of derivatives. This is a list of different type of problems that you may want to practice. Let's look at each of the questions here. If the cost function of the firm is given by, this is the cost function, find the average cost and marginal cost. Now, we'll have to remember the formulas here for sure, right? Without formulas, we'll not be able to solve these problems. Average cost is total cost by quantity. Total cost is nothing but the cost function, right? Total cost is nothing but the cost function. Put the cost function here. Quantity is always x, right? Quantity is always x, or they would have given in the question the number of units or number of products becomes the quantity. So here x is the quantity. So this is the average cost. Marginal cost is, remember always, whenever there is marginal word, it means you have to find the derivative. Whenever there is marginal, you have to find the derivative. Marginal cost, find the derivative of cost, right? That is derivative of the cost function. That's all. Now here, they've given you displacement expression, s is equal to 5t square plus 4t minus 8. Find initial velocity and acceleration. So whenever you have initial velocity, right, it means time is equal to 0. Time is equal to 0. T is equal to 0. Always. Initial velocity, t is equal to 0. Acceleration. Now what is the formula for velocity? Velocity is displacement by time. That is rate of change of displacement with respect to time. ds by dt. So s is given. Find the derivative. Initial velocity means t is equal to 0. Substitute t as 0. Right? So you'll get 4. So velocity is 4 units. Acceleration. What is the formula of acceleration? Double derivative. Second order derivative of displacement with respect to time. So double derivative of displacement. Right? d square s by dt square is acceleration. So find the derivative of this again. That is, you find the derivative of 10t plus 4 and you will get 10. So 10 units is the answer for acceleration. Third one. A stone thrown vertically upward rises s feet in t seconds, where displacement is given. What is the velocity after 2 seconds? Find the acceleration. See, this is exactly similar to the other problem. There it was initial velocity, right? Here it is velocity when t is equal to 2 seconds. Initial velocity, velocity is 0. Here they've asked to find velocity when it is 2 seconds, right? When t is equal to 2 seconds, you have to find the velocity. So same case, velocity is nothing but differentiate displacement with respect to time. That will give you velocity. Now substitute t as 2 seconds because you have to find velocity when t is equal to 2 seconds. So substitute t as 2, you'll get 16 units. Acceleration, again, it's a double derivative, that is d square s by dt, right? And put t as 2 seconds, so you'll get minus 32 units. Now, here again, similar problem, but here t is equal to 3, velocity is 0, and acceleration is 14 units. So first, we'll have to find velocity. What is velocity? ds by dt. They have told velocity is 0, so put v as 0. You'll have to find a and b here, right? You'll have to find a and b. So when I put velocity is 0 in this expression, I'll get 3a 3 square plus b is equal to 0. Now, similarly, I'll find acceleration. Acceleration is d square s by dt square. I'll put all of this, right? Now, t is 3 seconds here, right? They've given t. So substitute t here, t as 3 seconds in this expression. A you don't know. We'll have to find out a, right? So acceleration they've given, which is 14 units. Substitute acceleration. We don't know a, we know t. So you'll get value of a. Now you put this a in this particular expression and you'll get b. So we have got value of a and b both. Here, if the total cost of production is given by this particular cost function, find average cost and marginal cost. Simple. Average cost is total cost by quantity. Cost function is given. This itself is the total cost. Substitute that. Quantity is always x. This is the average cost. Now you have to find the average cost when output is 10 units. What is output? Output is x. Quantity. Output. All these mean the same. Output, quantity, x. All this means the same. So when x is equal to 10 units, you have to find this average cost. Put x as 10, you'll get the value. Marginal cost. Like I said, what is marginal? You have to find the derivative of cost. Marginal cost. So differentiate total cost. That is the cost function given here. You'll get the derivative. Substitute x as 10. X as 10, you will get marginal cost. Here, the radius of sphere is increasing at the rate of 0.5 meters per second. Find the rate of increase of its volume when r is equal to 1.5 meters. Now, first you need to find the volume of the sphere. What is the formula of volume of sphere? It's 4 by 3 pi r cube. This is the volume. You have to remember this formula. Volume of sphere is 4 by 3 pi r cube. What is it they've given? They've given that radius of sphere is increasing at the rate. Increasing at the rate. That means they've given dr by dt. Radius is increasing at the rate of 0.5 meters per second. So there is time here. So it's dr by dt. dr by dt is 0.5 meters per second. You'll have to find the rate of increase of its volume. Rate of increase. Rate of increase means dv by dt. Volume. Right? This is volume. You have to find rate of increase with respect to time. Always assume it's time. Right? So dv by dt. R is equal to 1.5 meters. They've given here. Take the formula of volume. Differentiate this. Remember one thing. Since you're differentiating with respect to t, right? When I find the derivative of r square, it will be 2r and I have to put dr by dt. Let's not forget this. I have to put dr by dt. Right? So now, instead of dr by dt, I'll put 0.5. I'll substitute 0.5 here. And r is already given. I'll substitute r also here. Then I'll get dv by dt. The next problem. When brakes are applied to a moving car, the car travels at a distance of s feet in t seconds. The displacement is given here. When does the car stop? You need to find at what time the car stops. So car stops when the velocity is 0. Of course, right? If the car is not moving, only then the car stops. That's what it means. If it's not moving, it means velocity is 0. Because velocity is displacement with respect to time. What is displacement? Displacement is change of position. Change of position with respect to time is velocity. Now car stops. That means there is no change in position. It stops. There is no movement. So displacement is 0. So therefore velocity becomes 0. Velocity is ds by dt. You have the displacement function. Put it here. Find the derivative. Velocity is 0. So equate velocity to 0. 20 minus 80t is 0. Therefore t is equal to 1/4 second. So car stops when t is equal to 1/4 seconds. Next problem. Very important one. If the sum of two numbers is 48, find the numbers whose product is maximum. When you add two numbers, it's 48. And when I multiply these two numbers, it's going to be maximum. Now, the moment I know it's maximum, it's double differentiate. It's double differentiation. Whenever there is maximum, it is double differentiation. Okay. So now first let me find the numbers. Let's assume the numbers to be x and y. X and y. when I add x plus y, it's going to be 48. That's what they have told. Sum of two numbers is 48. Now I can also say y is equal to 48 minus x. So basically one number is x, the other number is 48 minus x. If I take first number, the second number obviously is going to be 48 minus x. So I've taken the two numbers here. Product of two numbers is maximum, means its double derivative of this product is less than 0. X into 48 minus x, when I multiply, the double derivative is going to be less than 0. So first what I'll do, I'll take the single derivative. Let's assume that product is p, right? P is equal to x into 48 minus x. So I differentiate dp by dx. When I differentiate, it's going to become dp by dx. And I'll find the derivative, right? It will be 48 minus 2x. Now I'll have to equate it to 0. I'll have to equate this to 0, right? You'll always have to equate the derivative to 0. That way I'll get the value of x. So what is x? My first number, right? X is my first number. So I got my first number. What is second number? Obviously it's going to be 48 minus 24, which is 24 again. So the two numbers are 24 and 24. Now I have to verify that the product is maximum. We'll have to put this step, right? How do I verify if the product is maximum? I'll have to find the double derivative and see if it is less than 0. So I found the single derivative here. Now I'll find d square p by dx square. I'll find double derivative. What is double derivative of this? It's minus 2, right? So minus 2 is less than 0. It's negative. Therefore, we say product is maximum. Yet another problem. The radius of a circular plate is increasing at the rate of 2 by 3 pi centimeter per second. Remember, per second. That means it is with respect to time. That means it's with respect to time. Radius is r. Let's assume radius is r. So dr by dt. dr by dt is 2 by 3 pi centimeter per second. Find the rate of change of its area. You have to find the rate of change of its area. That is dA by dt. If you assume that area is A, let's assume area is A. So you'll have to find dA by dt. They've given dr by dt. We have to find dA by dt. And they have given radius as 6 centimeter. So what we will do, we'll have to take the area formula because we have to find dA by dt, which means I need to get the area formula. Area is pi r square. Area of a circle is pi r square. So if I differentiate, I'll get dA by dt, right? And then derivative of this is pi into 2r. Remember, dr by dt. You are differentiating r with respect to t. R with respect to t. So dr by dt. dr by dt is 2 by 3. Substitute. R also you have to substitute. R is 6 centimeter. So you will finally get, when I substitute R as 6, I'll get this 8 centimeter square per second. This is another problem related to revenue. Total revenue, total cost function of company is given. This is the revenue function. This is the cost function. Find the output at which MR is equal to MC. MR is marginal revenue. MC is marginal cost. You have to find the output. Output, like I said, what is output? Number of units. They've already told. Q is equal to number of units. Output means number of units. Q. You have to find Q here, right? You have to find the value of Q. So what is marginal revenue? What is marginal? Marginal means you have to differentiate. What you have to differentiate? Revenue. Marginal revenue. So you have to differentiate revenue. What is revenue function here? It's already given here, right? Find the derivative. Then you have to find marginal cost. What is the cost function here? 20 plus 4Q. So find the derivative of cost function. Now, you'll have to find the output when MR is equal to MC. So equate this. MR is equal to MC. They've already given here. Put marginal revenue expression, right? And marginal cost expression. Equate it. You'll get value of Q. 148 units. Now, next problem. Show that this particular expression has neither maximum nor minimum. Neither maximum nor minimum means double derivative should be 0. That's when you say the function is neither maximum nor minimum. So you take this function, differentiate it twice, right? Once you differentiate it twice, you'll get that it's equal to 0. Therefore, the function is neither maximum nor minimum. Next topic is integral calculus. Here is a list of different problem types. We'll cover some problems here. Evaluate this particular expression. You'll always have to check if there is derivative and function together. If you notice this is the function. Derivative of this function is 4x plus 3, right? What is derivative of 2x square? It is 4x. What is derivative of 3x? It's 3. What is derivative of 5? It's 0. So if you notice, the derivative and the function are in the same expression. When you have something like this, you assume that this denominator function is t and 4x plus 3 is the derivative. So you substitute t and dt here. So you'll get dt by t. Integral of 1 by t is log t. Then substitute t here. 2x square plus 3x plus 5 and then put constant. Here again same case. What is derivative of sin x? Cos x. So denominator is the function which is t. Assume that the denominator function is t and the derivative is the numerator. Don't take power. Only take the function. 1 plus sin x is equal to t. So this is going to become t cube when I substitute and this is going to become dt. Cos x dx is dt. Now take this t to the top. So it will become t to the power minus 3. So apply the integral formula and then you'll get this answer. Here this is also same case. This is the function and you have the derivative. Ignore the power. So t is just the function without the power. Find the derivative of this function. It is 8x minus 2. Here you have 4x minus 1. But in derivative we get 8x minus 2. So you take 2 as common. So you'll get 4x minus 1. You bring 2 this side. Why I'm bringing 2 this side? If I bring 2 this side, it's going to become dt by 2 and I'm going to get 4x minus 1 dx. Here I have 4x minus 1 dx, right? I have 4x minus 1 dx. So instead of 4x minus 1 dx, I'll substitute dt by 2 like this. dt by 2 and then instead of this function, I'll put t and then have this power 3 by 2. That's all. And then I find the integral using the integral formula. So here again, you have denominator function as 3 to the power x plus 1 and the derivative is in the numerator. Now this is of the form 3 to the power x is of the form a to the power x. What is derivative of a to the power x? It's a to the power x into log a. So instead of a to the power x, you have 3 to the power x into log a, which is 3. So this is there in the numerator. 3x into log 3 is in the numerator. Right? So I substitute t here and dt here like this. And integral of 1 by t is log t. Instead of t, put the original expression 3 to the power x plus 1 and you get the answer. Yet another problem. Here you have a rational function. So I can split this function. I can take common factor here. X is nothing but root x into root x. Right? So I can split x as root x into root x. I can write this as root x into root x. And then I can take root x as common. So I'll get 1 plus root x. Now you can assume that t is 1 plus root x. Let's assume this is t. Then if I differentiate, what I'll get? I'll get 1 by 2 root x. Here I have 1 by root x. But I have 1 by 2 root x here. So what I'll do? I'll shift 2 to the other side. I'll shift 2 to the other side. So it'll become 2 dt. 2 dt is 1 by root x dx. So 1 by root x dx I can put as 2 dt. 2 dt. And 1 plus root x is t. That's all. Yet another problem. Here again, derivative of e to the power x is e to the power x itself. Same case. So assume that t is e to the power x minus 1. Find the derivative. You'll get dt. Substitute dt here and t here. Integral of log x. Here what do? There's only one function here. How do we solve? So this is slightly tricky. But remember, when you have log x, assume that there is 1 here. Log x into 1. You can assume that there is 1 here, right? And then you can apply integration by parts. Use this particular formula. First function into integral of second function minus integral of derivative of first function into integral of second function. Go through my video for understanding more on substitution by parts, right? It gives a lot of examples. For more details, you can refer the playlist. Again, use the order late. Use this particular order: logarithmic, algebraic, trigonometric, exponential. In this particular order, you have to choose the first function. Since you have logarithmic function, that is you have log x, this should be taken as a first function. So log x is the first function and second function will be 1. Here what we will do is, in this trigonometric problems, right, you'll have to, it's a little tricky because you'll have to apply some compound angle formula or some trigonometric formulas to simplify this. I can write sin square x as 1 minus cos square x because sin square x plus cos square x is 1. So therefore sin square x is 1 minus cos square x. And I can write 1 minus cos square x as 1 plus cos x into 1 minus cos x. Now I'll cancel this and I'll get, I need to find integral of this. So it's simplified here. Now here, this is pretty simple one. Just integrate it one at a time. Integrate this first, integrate this first. That's it. Here, so whenever you have this, you have 1 by x. This is like 1 by x, right? What is integral of 1 by x? Log x. But instead of x, what do you have? 7x plus 8. So put 7x plus 8. And always put the coefficient of x in the denominator. What is coefficient of x? 7. Put it in the denominator. Now here this is of the form integral of a to the power x. Integral of a to the power x is a to the power x by log a. This is the formula, standard formula. So if you remember this, you can substitute directly. So instead of a, you have 7. And always remember to put coefficient of x in the denominator. Coefficient of x is 3. Put it in the denominator always. And this is the last problem here for integrals. X cube log x. You have product of two functions. You have to use integration by parts. Integration by parts. Which should be the first function? Use this form, late. Here you have log. So this should be the first function. This should be the first function. And x cube will be second function. So you will have to find integral of second function, derivative of first function, then again find the integral of this entire expression, and then you will get this as the answer. Last topic, definite integrals. This is same as integral calculus, except that you have to apply the lower limit and upper limit once you find the integral. So let's go through few key problems and their solutions. So let's find first the integral. You'll have to use integration by parts. So which should be the first function here? First function should be, you have algebraic function and you have exponential function. E to the power x is exponential. And this is algebraic. So you have to use algebraic first. So x is the first function. E to the power x is second function. This way. So first function into integral of second function minus integral of derivative of first function into integral of second function. Always remember, it's integral of second function. Integral of second function. You can refer the playlist on integral calculus for more understanding. Now once I get the integral expression, substitute the limits here, lower limit and higher limit. So instead of x, you put 2 and then put 1, subtract both and you'll get the answer. This is another problem. Integral of 1 by x is log x, straightforward, substitute. So x as 2, log 2, then x as 1, log 2 minus log 1. Log 2 minus log 1, use logarithmic property. Log m minus log n is log m by n. So log 2 minus 1 is log 2 by 1, which is log 2. Similarly, third one also, right? Separately find integral of this, then apply lower limit 0 and higher limit 1, and you get 2 by 3 as the answer. Here, you assume that this is t and differentiate this one. So you will get 2, but you have 1 in the numerator. So what you can do, dt by dx is 2. Therefore, dt is 2 dx. Right, dt is 2 dx. Therefore, dt by 2 is dx. You need to substitute dx here, right? So bring 2 here. So it will become dt by 2 is equal to dx. So instead of dx, I put dt by 2. I put dt by 2 and then I have t here instead of 2x plus 3. Right, simple. Now, once I get the integral, apply these limits. So when you have this log 7 minus log 5, is nothing but log 7 by 5. This is another problem. X cube plus ex, find the integral and apply the limits. Integral of cosec square x from minus pi by 4 to pi by 4. Pi by 4 is 45 degrees. So put cot 45 here. Cot 45 is 1. So you get the answer as minus 2. Let's go to the next problem. Integral of x's. These are all simple functions, just that you'll have to put the lower limit and upper limit after finding the integral. So with this, we've come to the end of this particular video. I hope you found this video useful. If you have liked this video, do press a like and share it. Thank you.